Okay, so what if your IT systems could actually heal themselves before they even break? We're going to talk about an AI today that does exactly that. It predicts failures and then fixes them before anyone even knows there was a problem. And look, this isn't just some small upgrade. It's a totally different way of thinking about how we keep our digital world up and running.
So, to really get why this is such a game changer, you've got to start with this number 80%. Think about it. Every single day, IT teams are just flooded with alerts, and the research shows that a whopping 80% of those alerts, totally benign. They're just noise.
But here's the thing, right? The other 20%? That's where the real danger is. Buried somewhere in that massive pile of noise are the few critical alerts, the ones that are basically screaming that a total system failure is about to happen. You miss just one of those, and your entire service could go down. Poof.
And that leads us right to the heart of the problem for IT teams today. It's this constant, never-ending storm of alerts.
Yeah, there's this quote from the research that just hits the nail on the head. It talks about alert fatigue. I mean, it makes sense, right? When you spend your whole day just sifting through thousands of false alarms, what happens when a real crisis pops up? You're just slower to react. And in the world of IT, every single second you lose in that response time can cost you big time.
So what's the solution? Well, you can't just throw more people at the problem, right? Having more eyes on more alerts doesn't fix the core issue. The answer is a completely new way of thinking. It's about building a system that's less like a firefighter and a whole lot more like a doctor.
And I love this analogy because it makes so much sense. On one side, you've got the classic IT firefighter. They're always reactive, right? Just running from one fire to the next, putting out emergencies after they've already started. But on the other side, you have this new model, the AI doctor. This is all about being predictive. It's doing routine checkups on the system, looking for those silent killers, the slow memory leaks or the creeping disk space issues, and it steps in to fix them before they can ever cause an outage.
So, okay, here's the more formal definition of what we're talking about. It's an AI-driven system that proactively detects, diagnoses, and then auto-remediates those hidden, lurking failures. And it does it before they cause a real outage. The key words there are huge. Proactive, diagnose, auto-remediate. It doesn't just see a problem, it understands it and then fixes it, all by itself.
Now, I know this sounds a bit like science fiction, but it's actually built on three very real, distinct AI technologies that all work together. So let's pop the hood and take a look inside this AI's brain to see how it actually pulls all this off.
Okay, first up, we've got something called Agentic AI. The easiest way to think about these are as the hands of the system. They're the doers. And we're not talking about simple scripts here. These are autonomous agents that can actually make a plan and then execute really complex tasks all on their own. Things like rerouting network traffic or spinning up more servers when things get busy.
Next, you have RAG, which stands for Retrieval Augmented Generation. Now, if the agents are the hands, RAG is the brain. This is what gives the system its memory. It allows those AI agents to instantly dig through years of old incident logs, technical docs, you name it, to find context. So when a weird new problem pops up, the system can basically say, I've seen something like this before, and this is how we fixed it last time.
And then there's this, which is just brilliant. This is the safety net, the digital twin. It's exactly what it sounds like, a perfect virtual copy of the live running system. So before an AI agent goes and applies a fix to the real world, it tries it out here first, in this safe sandbox. It's like a flight simulator for IT fixes. This makes sure the cure isn't actually worse than the disease, All right, so we've got the hands, the brain, and the safe testing ground. Now let's put it all together and see how these pieces work in this constant, self-healing loop.
It really boils down to a four-step dance. Step 1, detect. The system is always watching, and it spots something that looks off, an anomaly. Step 2, diagnose. An AI agent wakes up, uses that RAG brain to dig into historical data and figure out the root cause. Step 3, test. It comes up with a fix and tries it out in that safe digital twin simulator. And finally, step 4, remediate. Once the fix is proven to work, the agent automatically applies it to the live system. And this whole cycle, it's running 24/7, just constantly watching over the infrastructure. Now, for anyone who's a little more on the technical side, here's a quick peek at the architecture. You can see a lot of modern tools in here: Kubernetes, Prometheus, the usual suspects. But a couple things really stand out. They're using Qdrant as a vector store, which is super fast for that AI search. And I thought this was really clever. They're using Llama to run the AI locally. That's a huge move for keeping costs down.
Okay, so that's the how. But what about the so what? What's the real world impact when you actually make this shift from being reactive to being predictive? Well, the impact is huge. The research found that putting this AI healer in place led to a 70% reduction in what's called operational toil. That's all the manual, repetitive, soul-crushing work that burns out really talented engineers. 70%. I mean, that's not an improvement, that's a revolution. And this slide just lays it all out, the before and after. You go from the old way of manual work, alert fatigue, and long fix times to a new world of automated diagnosis and predictive healing. It crushes something called mean time to resolution, basically how long it takes to fix stuff. The whole operation becomes proactive, solving problems before your users even have a clue anything was wrong. So, the big takeaway here is that this isn't just another tool. It's not a fancier dashboard. This is a fundamental change in how things are done. This is pretty much the future of how we're going to manage all the critical infrastructure that we all rely on every single day. And that really leaves us with this one final, kind of exciting question to think about. When we automate away all that grinding maintenance and firefighting, we're not getting rid of the humans, we're freeing them. So the real question is, when our infrastructure can finally heal itself, what amazing things will our smartest people be free to build next?